Hey girls! Today we're going to be talking about solving quadratic equations by graphing. As a reminder, quadratic equations are anything with x to the second power in them, and solving means that you're trying to figure out what value of x will make the equation true. So your answers are going to be in the form x equals some number, and there's some different names for these solutions. They could be called roots, zeros, or x-intercepts. Those are all kind of similar and mean the same thing of what we're looking for here. And with a quadratic equation, it's helpful to keep in mind that you can have 0, 1, or 2 real answers because of that power of 2. In a quadratic equation, there are 4 different methods to solve them, which we kind of touched on in chapter 2, but we didn't go into very great detail. Those 4 methods of solving are graphing, factoring, completing the square, and using the quadratic formula. The last 3 methods are all of your algebraic methods, which we'll get to later on in this chapter, but for today we're just focusing on graphing. The bad part about graphing is that it doesn't always give you exact answers. Then you would have to rely on your algebraic methods. So we might have to estimate some of our answers today, but the thing is, you're just basically graphing the quadratic function and then looking for where does the graph cross the x-axis, or looking for what are the x-intercepts of the graph. So we have to review how to graph a quadratic function. Let's get into it. All right, think back to your lesson from last week. Let's say we were trying to solve this equation by graphing, and we were given this function, or this equation, x squared minus 3x minus 4 equals 0. You want to make sure it's in standard form for a quadratic first, meaning it's ax squared plus bx plus c, all on the same side. The other side should be set to 0. So you'll notice, like in example, the next example for b, it's not in standard form yet. So you would have to move some of these terms around. I personally like to have it a positive x squared, so in this case, I would move all my terms over to the right side, meaning I'll also have to move the 14 over. On the left, everything's gone, so I would have 0 equals, then I would have x squared, then the negative 6x, and then positive 9. Now that it's in standard form, now I can graph that. That's always the first step, is to put it in standard form. Once it's in standard form, then you can get back to what we talked about with graphing. So think back, what's the first step to graph a quadratic function? The first step is to identify a, b, and c in standard form. In this case, a is 1, b is negative 3, c is negative 4. Find the axis of symmetry. Use the formula x equals negative b over 2 times a. So on this one, it would be negative times negative 3 over 2 times 1. The opposite of negative 3 is positive 3, and then 2 times 1 is 2. You can leave that as a fraction, 3 over 2, but since we're trying to graph this, I would probably suggest making it a mixed number, or a decimal in this case would be fine, because it's exactly 1.5. That's where your axis of symmetry is. X equals 1.5. Remember, that's a vertical line, and it's not really part of the graph. It just shows us where is the graph cut in half. So go ahead and draw it either in a different color or use a dotted line right between the 1 and the 2 on the x-axis. Once you find the axis of symmetry, that's the line that cuts the parabola in half. We know the vertex has to be somewhere on that line. To figure out where the vertex is, you're going to take the value that you got for x and plug it back into the function. So you'll have 1.5 squared minus 3 times 1.5 minus 4. That's going to give us the y value. Remember to follow PEMDAS, and for this one, you should get negative 6.25. So putting that together, you have the x is 1.5, the y is negative 6.25. That makes the coordinate 1.5, comma, negative 6.25. graph that as the vertex on the graph. You're going to have to estimate a little bit there. After you get the vertex on the graph, the next step is to look at the y-intercept. Remember, the c value tells you the y-intercept. So if the c value is -4, it means the y-intercept is 0, -4. You can take that y-intercept and reflect it over to the other side on the axis of symmetry. So that would be the point 3, -4. And another thing you can do is also to look at the a value. Since this equation has an a value of 1, it means that to get to the first point on each side of the axis of symmetry, you would go up 1 over 1. So that's going to be about here and here. Now that's not super helpful on this problem, because it doesn't land on an integer or anything like that. But so far, we can see our U shape looks like this. It's looking good so far. It's pointing upward or opening upward, which makes sense with our positive value for A. But we're not even close to the x-axis yet. In order to find some more points on our graph, what we can do is we can make a table to get closer to the x-axis. We already know that it's not going to be anything between 0 and 3 on the table because we already have points for that. Those aren't going to be the x-intercepts. So let's pick another point besides a number between 0 and 3. For example, let's try 4. If we plug in 4 to our equation for x, let's find out what do we get for y. So go back to your equation, but instead of x, replace it with a 4. So you would have 4 squared minus 3 times 4 minus 4. That ends up giving us 0. So for 0, that is an x-intercept. That's really great. That's what we're looking for. Remember, solve means that you're looking for the x-intercepts is another word for the solutions. If 4, 0 is a solution, then we can reflect that over the axis of symmetry to know that -1, 0 is another x-intercept. So here's a picture of what our graph looks like. And once you have a great looking graph, you're going to use the x-intercepts as your final answers. This one has 2 x-intercepts, so you have 2 answers, x equals -1 and x equals 4. Go ahead and try graphing the other 3 on this page and figure out where do you think the x-intercepts are. Alright, here's an example, another one where it's the one on the top right, and it only has one final solution. It's just x equals 3, because that's the only place it touches the x-axis. Whenever you have the vertex is the same as the x-intercept, that's a case where you're only going to have one real solution. It can also be known as one repeated real answer, and we'll get into why it's called a repeated real root later on this chapter. Similarly, for the practice problem with capital A on the bottom left, you are going to end up with just one answer. It was x equals -4 since the vertex is on the x-intercept. And then for problem B on the bottom right, you should end up with 2 answers, x equals 2 and x equals 6, because after you change it to standard form and you graph it, you get those 2 answers, 2 and 6. Okay, I wanted to show you one last example of solving by graphing. Just in case you run into one like this, let's take a look at if you had to solve by graphing x squared plus 4 equals 0. It's already in standard form, and we can figure out the a is 1, the b is 0, the c is 4. So when we go to find the axis of symmetry, it ends up being the y-axis, because 0 divided by anything always equals 0. And then when you plug that back in, you find that the vertex is at 0, 4, which also should make sense if you think back to chapter 2, because this is just your parabola shifted up by 4. It's the function x squared is the parent function, and then the plus 4 is outside the parent function, so that means the entire graph got shifted up 4. Since it's opening upward, it never touches the x-axis. So when you go to write your final answer, the final answer would have to be no real solutions, because there's no spot where this touches the x-axis. It's not possible to plug in any value for x, square it, add 4, and get an answer of 0. That's just not going to happen. So that's where our imaginary numbers will come into play, and we can talk more about how to find those imaginary roots once we get into our algebraic methods. But for now, if you're solving it by graphing, you would have to just put no real solution when it doesn't have any x-intercepts. All right, if you have any questions about graphing these and finding the solutions or the x-intercepts, let me know. Hopefully those made sense, and you can work on the EDA practice problems to help you practice solving quadratics by graphing them. Thanks, guys. Bye.